Hi, everyone. I'm Anastasia, President of U.S. Harbors, and we're thrilled to be here today with Dr. Jyotika Virmani.
Hello.
So Dr. Virmani has advanced degrees in both oceanography and ocean-related meteorology, topics which are very close to our hearts here at U.S. Harbors. She has had and continues to have a fascinating career. In addition to her current position as the Executive Director of the Schmidt Ocean Institute, she's also been the Executive Director for X Prize's Planet and Environmental Challenges, including the recent Shell Ocean Discovery Program to accelerate innovations in unmanned deep sea mapping technologies. Welcome to Woman on the Water, Dr. Virmani.
Thank you. I'm Dr. Jyotika Virmani, and I live in Los Angeles, California.
And how do you describe yourself and what do you do?
I would consider myself an ocean atmosphere scientist, an oceanographer and an atmospheric scientist. But I also have done a lot of work with marine technologies. I tend to look to the future. I like looking at the future and working with technology. Really, what I am very passionate about is bringing new technologies into the marine realm, because it's a really difficult environment to work in to make everyone's lives easier.
So tell us a bit about your life growing up and how you got into this fascinating field.
I grew up in Manchester in the United Kingdom, where the joke was that it was always rainy. So we were obsessed with the weather, if you like. So I grew up, like loving the weather, talking about the weather in the entire UK. That's one of our national pastimes, I believe. And so as I grew older, I got into physics. And actually, I originally wanted to be an astronomer. And I lived near Jodrell Bank, which is the largest radio telescope in the world at that point in time. So I really wanted to do astronomy, but then I took an atmospheric science course in my undergrad at the same time as I did an astrophysics course. And so that really pulled me a little bit more to earth. And then as I got more and more involved in that, I realized, the connection between the ocean and the atmosphere really controls and drives our climate and our weather systems. So I then did a physical oceanography degree, PhD, which is after doing an atmospheric science master's degree, which is about the physics of the ocean and how the ocean and the atmosphere interact to control our weather and our climate systems. So I guess you could say, my career has been downwards from the space, down.
Complexity of ocean and atmosphere and how important that is to our planet. Can you speak about how we should think about these things?
What's really remarkable is how connected we are globally. So to me, one of the appealing things about studying the weather and climate is it doesn't matter where you live, how rich you are, what your job is, you're always going to be impacted by weather and climate. Whether you live on the coast, as you well know, there's, ocean influences, but even if you live inland, weather off the oceans can actually impact what's going on there. So it's really, really a fascinating system to look at and to study. And it's between the ocean and the atmosphere and the sun. Those are our three major influences on our weather and climate. And then you add in things like the land mass and the cryosphere, the ice. So you have, essentially 5 components that make up and control all of our lives.
Can you tell us a little bit about your work in meteorology and what you've done in that?
Yeah, so I did my PhD in physical oceanography at the University of South Florida. And while I was there for the 2004-2005 hurricane seasons. And so my PhD was really going into the Gulf of Mexico. We had moorings and from which we collected meteorological data as well as subsurface ocean data. So I was looking at, the interactions of heat and other fluxes between the ocean and atmosphere. But when we went through those hurricanes, we had some major ones in Florida in 2004 and 2005. I really started to utilize my science knowledge and track and follow these storms and see what the data was showing. And so since then, you know, I started a blog just for anyone to follow, and I try and use it to show, well, and this is, by the way, a hobby. It's not my actual job, but I use it to show, you know, where the data is so that you can see for yourself what it means. So here's some satellite data. This color means this, and this means that. But it's a hobby, so it's kind of a fun thing, and I do it when I can. And sometimes, unfortunately, I don't have time to do it. So that's my hobby side of what I do and how I apply it. What I do for a job is really fascinating as well. If you want, I can go into that now, or we can wait.
Sure, yeah. Tell us about your work at the Schmidt Institute and what you're doing there.
Yeah, so the Schmidt Ocean Institute was started in 2009 by Eric and Wendy Schmidt, and it's a philanthropic effort where we provide a state-of-the-art research vessel and facilities, including a high-performance computing system and a very sophisticated advanced underwater robot that can go down to 4,500 meters depth. And we provide all of these at no cost to oceanographers and researchers and scientists, and even people who develop technology, marine technology, to go out at sea and to look and explore and investigate what's going on out there. And the reason that we do this is because going to sea is so expensive that this is a huge component of people's research funding and dollars. So by providing this at no cost, our basic request is that we ask scientists to make their data publicly available. So, for example, last year we gave over 1 million square kilometers to a global effort that's mapping the seafloor, CBED 2030. So all the data that we collect goes into the greater domain for anyone and everyone to use. And we've had some really, really fascinating findings this year. Back in April, we announced the discovery of the longest sea creature, siphonophore. And what it really shows is, even though, you know, we live on land and we know what's around us, the ocean is just so vast and it's so unexplored and unknown that a creature that's about 150 feet in length has never been seen until this year. And that's just, you know, that was by chance that we happened to find it. But what else is out there? I mean, it's a new planet. We've no idea what's out there. So it's kind of fun to do this exploration and also improve our understanding of our ocean systems.
How is mapping the deep sea different than mapping on land? I mean, besides that you use a boat.
Yes, actually we use a boat, but for the Shell Ocean Discovery X Prize, the competition that I ran over the last few years, that was really to push for unmanned and autonomous technology to map the deep sea floor. So, you know, when we launched that competition, which was at the end of 2015, only about just under 5% of our ocean floor had been mapped to any great detail. And, you know, the ocean covers 70% of our planet. So most of our planet is an unknown. And part of the difficulty, of course, is going back to your question of how does it differ from land mapping versus ocean, is we can't see it. And there's this big body of salt water between us and the sea floor. But if you think about it, if we could remove that, what we'd see is an alien landscape where you have cliffs that are 2 kilometers, you know, in height. If you could go down there, they just like drop for 2 kilometers. If you came across that on land, you'd be looking at one very, very, very long wall of rock. So, and there's so many seamounts down there. So there's a lot of stuff. So that competition was to really get technology that will allow all of us to map faster, more cheaply, more quickly. So between the vessels, the ships that like the RV Falcor that the Schmidt Ocean Institute operates, and these new unmanned technologies, I think we can get a really decent resolution of our whole planet by 2030.
So can you talk a little bit about this 2030 goal and what this program is and who's working on it?
Yeah, so CBED 2030 is a global effort that was launched or announced in 2017, and it's funded by the Nippon Foundation, and it's run through an entity called GEBCO, the General Bathymetric Chart of the Ocean, which is overseen by the International Hydrography Office and the Intergovernmental Oceanographic Commission. The goal is amazingly simple, which is why it's very easy to talk about. And the goal is to map our seafloor at a high resolution, let's say even 100 meters grid size, by 2030. So before we launched that X Prize back in 2015, the estimate was it would take us, with the technology of the day, 200 to 600 years to map the seafloor. And now we're looking at trying to get this done by 2030.
Can you describe the vessels that you're working on and what it's like to experience that?
So the RV Falcor, which by the way was named after the luck dragon in Neverending Story, and our underwater robots called the ROV Sebastian, also very thematically named after Neverending Story. It's an amazing vessel. It is a research vessel, so anyone who's been on research vessels will be familiar with that. It has some, like I said, it has the ROV capability, which is an underwater robot. We actually do transmit live underwater footage. So we have a YouTube channel where you can see past dives. So, you know, over the summer, even with the virus, we had no scientists on board. We actually did a remote telepresence cruise because of our strong, you know, ability to communicate back to shore. So the scientists were sitting in their living room or bedroom or wherever it is at home, just like the rest of us. And our crew were at sea and doing the work. And as a member of the public, you could actually follow along and listen to and get the commentary and the discoveries live as the scientists found and saw things. So that's really fun. So so yeah, definitely for anyone who wants to check out the Schmidt Ocean YouTube channel, there's a lot of fun footage.
What are your thoughts about what's going on with the climate these days, and what are your observations there and thoughts about the direction with that?
Yeah, so so there's a quite considerable body of data now to show that temperature is rising, and looking at the reports, we really need to try and halt that temperature rise. And there is, there's the carbon dioxide connection that's been made. But even if you stopped CO2 input into the atmosphere today, the temperature would still continue to rise because the planet has an inertia to it. The whole system has an inertia to it. So it would still take decades before the temperature stopped rising. And so what we really need to do is work out there's everyone working on the carbon dioxide issue should definitely carry on, because that's cleaning up not only carbon dioxide but nitrous oxides and everything else that we're putting into the atmosphere. This is the air we breathe, right? But I think we need a separate effort to really focus on how do we stop temperature from rising, at least in the short term, till we clean up the atmosphere. Because once that temperature rises beyond a certain point, like over 1.5 degrees to 2 degrees, we start to see some longer term ecosystem changes taking place that are going to be very hard to reverse. So, so that's one thing that I, really am following, is how do people, like, what are the solutions to try and stop temperature from rising in the atmosphere? And like I said, it doesn't have to be forever, at least till we sort out our own atmosphere. Now, what the coronavirus has done, of course, with in the early days, everyone was at home, traffic was reduced. So that was really interesting, because now the projections are that this year at least we'll see something like I think it was something like an 8% decrease in CO2, which, you know, even with 2 to 3 months of lockdown is amazing. Unfortunately, we can't do that every year for the next decade. That will be very difficult. But yeah, I think it's a very complicated issue, and I think we need to start looking at temperature explicitly.
How do you describe your relationship with the ocean?
I've always actually approached it scientifically. So I think because I was a physicist, and my real interest was how does it interact and control our weather and our climate system, taking it back up to the atmosphere now. I think my relationship is one of respect, because I could see, you know, when I follow storms, the power and the majesty of nature is just so massive, and so it really shows you, you know, we are one small piece on this planet. So that's my how I would perhaps describe my relationship. By the way, this next decade is the United Nations Decade of Ocean Sciences. So I hope to look back in 2030 or maybe 2031. We'll give everyone an extra year here. Look back and have a before and after, where in this next decade we have discovered so many new things. If you are interested in following the adventures and finding things in the deep sea, we have a website, the Schmidt Ocean Institute.org, schmidtocean.org website. We actually also do an Artist at Sea program. So we actually have an art gallery where we invite an artist on board with each science cruise to talk to the scientists, to see what's going on, and then to create a piece of art. So that's also something that's tangential but interesting.
That's great. Thank you so much for joining us today. It has been a great pleasure to have you, and good luck with all of your programs, and we'll be looking forward to seeing what comes out of it.
Thank you. It was an honor to be invited. Thank you, Anastasia.
Thanks.